Let's do it. Welcome back again. We're so excited you all spent this time. You've been working hard. You've been preparing for this thing. It's on. You're ready to do it. This is our space vehicle wrap up. Hopefully you all built some rockets. Before we get started, let me do a very quick poll. It's lunchtime. I have to do a quick poll. Monica, I hope you're testing this out for me. Jump in the chat. If you had to choose one meal to eat every day, what would it be? You're an astronaut, aren't they, Monica? Are they astronauts? You got a meal. You can eat this one meal every day. What's that meal? Or you can place it in the chat. If Slido's not, oh, I got
Ooh,
some
we
mac
got
and
some chat. Yes.
oh, a little pizza.
Pizza.
Oh man, I love pizza. I'm getting hungry. I skipped lunch because I was just watching y'all build up. I probably should have eaten something. We got a
Ooh,
little, does Diet Coke count?
we got
Someone likes a little 4202238. Matter of fact, go to Slido and type that number in, and then you can kind of post. Got a little buffalo chicken out there, some burgers. Oh, Jen, I remember that burgers, fries, Dr. Pepper. Oh, nice. Someone said fruit. Look at you, just healthy. They're just healthy, man. That's great. I love some spaghetti. My wife makes a wonderful spaghetti. Jollof rice. Maybe I should just, let me put the chat up here. All right. Jollof rice, right? Great stuff. Excellent. Someone agrees with red beans and rice with fried chicken. Bring it. Milton, do you have Instagram? I don't know. I think so. ET has Instagram. Maybe we can post that. Mashed potatoes with hot dogs. That is fried plantains. Hey, nice. Someone said a Lunchable. I'm not mad at it. That's good. I think those Lunchables last forever, Monica. I don't think
I
they.
agree. I don't know if I want to eat that for a whole
I
month
don't
though.
know. Grandson's chocolate cake. Never heard of that. Okay, excellent, cool, great. Thanks, Constance. Engineering Tomorrow is on Instagram. Hashtag Engineering Tomorrow. Give me a shout out. Give Betsy a shout out. Monica, Constance, Jillian, Jen, all of them. All right. Fanny's Rib Rolls. Okay, great. All right, excellent. This is good. Okay, here are some of my favorites. I like some deep dish pizza. This is Monica's paella. Did I do it?
Paella. Very
Ah,
close though. You're getting better. You're getting better.
all right, all right. And here is some good old gumbo from Constance. But even better, space food. Betsy, talk to us about space food.
Yes. Oh my goodness, you guys. So when you go to space, you're probably thinking like, I need to eat, right? Like, how am I going to carry up half a year's worth of my food? Well, a lot of times the food will be set up in what we call these like dehydrated bags. They kind of remind me of those little pouches that you would see like applesauces in. And they have these straws that are stuck into them. And then we can insert that into our water system and then have the water go through the tube and then rehydrate some of these bags that might have like macaroni or other kinds of foods inside them. You can also see here, it's a super huge, wonderful day when the Progress vehicles or other resupply vehicles attached to the space station, because when they do, fresh fruit arrives. And so you can imagine we can't keep fresh fruit too long. So the crews always have this super huge smile on their faces when the fresh food arrives and they get some tasty stuff to arrive.
Thank
That's
you,
it for
Betsy.
me. Of course.
Excellent. Man. All right. Last question, and we're going to jump right in this thing. What did you enjoy the most about this lab? What did you enjoy the most? I'll place this up here as well. We can see you in Zoom. Monica, did you build your rocket?
I did not. Jose didn't get me a kit.
Someone said winning. I love it. The presenters, hey, thank you
Yes.
so much. Blowing balloons this night, launching balloons. Oh, we're cooked. I think we're ready. Watching other groups fail, spectacular. This is a competitive group, Monica. I can't wait to see some nice competition. This is a competitive group.
Yes.
All
And we
right.
had somebody say in the Q&A that their balloons didn't make it. So we had some balloons that didn't make it, but
Okay.
that's okay, right? Failure is part of the process, right, Milton?
Yeah, it is. People used to say failure is not an option, but it is. The more we fail, the more we learn. Someone's getting some more clips up. That's great. Oh man, I think we're ready. I think we're ready, Monica, Betsy, to see some designs. Let's do it. So it's your time to shine. this is your time. Monica's gonna hook us up. She's gonna call out some schools.
Yeah, if you
Whoever's
want us
ready.
to spotlight your group, please raise your hand in Zoom and I will spotlight you for everybody. You can unmute and share. And I think I see some groups that are preparing. I see East Harlem looks like they're ready. Monsignor Farrell looks like they're ready. Who's ready first? Anybody want to be the first one? Oh, I see some Northeast High School has their hand raised. Can you unmute Northeast High School? Let me see if I can. Oh, he had his hand raised. Now he has his hand down. With
Oh, oh man.
You're not ready for us? All right.
If this shit doesn't work, I'm gonna cry.
Or East Harlem, I'm spotlighting you.
Oh.
Oh,
That's like a 4 rocket, a quad rocket. Sheesh. Okay, East Harlem.
East
Great-
Harlem, does somebody want to
great
come up
job.
and talk to us about what
Killing
happened
it.
there?
You're killing it. Oh man. Oh, okay.
Do you want to chat with us, East Harlem?
Oh, we have one more.
One more? Let's see it. Oh,
Oh, nice. I don't think they can hear us, Monica.
Hang on,
hold on. I think
Have
they're
at
gonna
it.
launch
That's
this
all right.
pink balloon right now.
2, 1. Who wants to chat with them and do the explanation? Come quickly.
East Harlem is awesome. Come on, don't be afraid.
All right.
Oh, nice.
Ooh.
Man, that's a high ceiling.
Over there.
High ceiling as well.
All right.
Let's do another school. All right.
Over
Great job.
See if I can. I see Dr. Anthony. Let me see if I find his little square. Somebody find Dr. Anthony.
Yeah,
He said
teamwork
his group is
teamwork.
ready.
Okay.
Can you unmute Dr. Anthony? I don't see his
Okay.
little square.
Are you talking to Dr. Anthony at Bladensburg
Yes.
or another Dr. Anthony?
That's
okay,
you.
My students are at lunch, but we
Oh,
did
no.
we did have some that were actually successful. So I'm gonna send the videos over to you guys a little later, and then we'll do the same thing with the B-Day students
Oh,
tomorrow.
fantastic.
Okay.
All right.
Great.
Monsignor Farrell, you gentlemen ready? Monsignor Farrell, you gentlemen ready? Can you unmute?
We actually demonstrated one about 2 minutes ago live. It was
Oh
successful.
man, we missed it.
I took a video. I'm going to send it to you.
Oh,
We're missing these live launches.
yeah, we're missing the
Can-
launches.
Can somebody come up and chat with us and tell us how it went?
Somebody want to talk? What did you learn about the design? Go ahead. Tell what you learned about the design.
So that should be right everywhere. President.
Nobody wants to speak.
I love the best. I
They're
mean,
suddenly shy.
so
Oh,
professional.
they're
I love
suddenly
it.
shy.
It's okay.
All right.
Duval
All
is
right.
ready.
Come on, Duval, bring us home.
Duval is ready. I just don't know which camera to go to for Duval. Oh, I think I found it. Duval, you ready?
Oh, look at the cup. Nice.
There we go.
Yes, we are. Y'all ready?
We're ready.
You're in the camera. I'm gonna let you know you're in the camera.
Okay. We are on camera. Could you please be quiet?
Okay, that's get 'em- that's right. Get them right. Get them right. Okay.
Wait. We're waiting on y'all.
All right.
What are you guys gonna illustrate something?
Yeah, we want you to launch this rocket. Yeah, let's do it. Ooh, he has some scissors too. He's okay. Oh, he's setting it up, Monica. This is good.
Oh.
Oh,
Oh.
great try though. No, it was great. It was great.
All right, Monica, we are ready.
We have some good ones on video we'll send over.
All right.
Excellent.
Sounds
Thank
good.
you.
Thank you. I see Stefan Decatur has their hand up. Are you guys ready? But your camera's off. Are we ready?
Which one is the main?
Okay.
Froze for a minute.
Are you guys ready?
She needs to reattach it real quick.
Hey, how's it going?
How many paper clips are on it? 18 paper clips.
18 paper clips. Let's go. Oh, it's going down to the bottom, Monica. We're nice. Excellent. In the
Very
time.
nice.
What? Okay. All right. You all better watch out. Watch out. Stephen Decatur came in strong.
All right. I have two hands up. I have Queens High School for Language Studies wants to show us their launch. All right, you guys
Oh,
can unmute now. Look at this.
sheesh, look at that. Serious. And I hope they get somebody to talk us through it as well.
Let's see.
I
Can
mean,
you guys unmute?
we gotta have
Oh,
someone.
here we go.
We gotta
Nope.
have somebody talk us through it as well, man. That's an awesome design.
This looks
They're trying.
Chris, here you go.
Nice. Okay. All right. Okay. Setting it up. I get it. Multiple cups, multiple balloons.
this is an intricate launch that's happening, Milton.
Oh, it's serious.
We need some assistance. Here we go.
Yeah, we got launch day support. Oh,
Oh,
maybe one more time. We'll come back. It's such
All
a
right.
good design. We'll come back.
we'll come back.
We want to see it.
East Harlem says they're ready again. Ready for East
Okay.
Harlem, Milton?
Yeah, I'm ready. I'm
All
ready.
right. See.
Okay.
You're ready? You're ready?
Yeah, let's do it.
We're ready. East Harlem, you can unmute.
Okay. Oh man, that was a launch assist. That was a launch assist.
I was gonna say they had some assistance there.
Had the same thought.
Great job.
And we have one more school that has their hand up. All Nor. You ready, All Nor?
Let me raise it again, just in case.
Are we
All
ready?
Nor, you're on camera.
Okay. Let's do it. We're ready. We're ready. You setting it up? Yeah,
Uh-huh.
you on. Your time to shine. All right. There's a setup. Okay. It's getting the team together. That's good. Hey, how
Hey.
you doing? Thanks for letting us into your space today. In a space day, Monica.
These designs are just very complex, right, Milton?
Yeah. I like, dual system, dual rocket. I mean, sheesh. Oh, somebody's over there pumping. Nice. They're getting ready. Okay.
Does somebody want to tell us what's happening in the classroom and talk to us?
We would love some conversation. We love some interaction. Oh,
I don't think you're unmuted, but we can't hear you. I don't think their mic is working.
I don't think so either. I think they may need a little more time. Are you ready
All
to
right.
launch? No.
Are you guys ready to launch? Yes, I see some thumbs up and some fingers shaking no. Okay,
This
we'll
is
come
like-
back.
This happens on a real launch day. Like there's some thumbs up and some thumbs down. Like we're ready. No, you're not. Weather says you're not ready. No, we're not. So hey, we understand. We got one successful launch. I think we need 5, Monica. If we could get 4 more. If
I
we
know
could get
Queens
4
High School
more.
wants to try again. I don't see anybody else's hand up. So let's go back to Queens High School for Language Study. You guys ready now? I see a lot of movement. You ready?
Uh-oh.
No, it was a failed launch.
Failed launch.
man. That's all right. That's all right.
right.
Okay.
I think Milton gonna have to take this one. Maybe some assistance, maybe some design assistance.
Yeah, we're definitely here to help. Any questions for us?
Does anybody want to talk about their failed launch?
Yeah, get a couple students, get a couple teams.
Don't be shy.
I know Duval's out there, but love to get.
Oh, I see a hand up. All right, here we go. You ready? You can unmute. Oh, live launch happening, Milton. Live launch. You ready?
Coming
Yeah.
in from Louisiana.
Yeah, let's launch it. Oh, did we miss it already? Oh.
Yeah.
Bo
Oh,
Shane High School.
man. All right. Anybody else want to raise their hand and try? You know what it is? I think that synchronized launching is difficult.
We're gonna launch. We just need 2 minutes. We're having a technical issue.
Oh,
All right, you let
that's
us
how
know when
launch
you're
day-
ready.
Yeah, launch day technical issues, man. All good.
We were ready, but
A little feedback from Northeast. It seems to be a timing issue, Milton. We're missing the right time to catch
Yeah.
these launches.
Also, I don't know this school, Ishmael Kamara. They have some serious rockets in there. Yeah, I want to see Ishmael
Let's see.
Kamara's.
Let's see if I
Yeah.
can spotlight there.
Yeah.
I see.
Launches. You want
No
you wanna
launches?
launch?
Nobody wants to chat with us?
Look at them. No, like, look at they put the hands over their face.
No.
Hey.
Oh,
All right.
man.
Yeah,
Look at
we-
these.
look at that nice rocket. Launch it. Come on. That's a nice rocket. Launch it.
Oh, we got somebody with their hand up. Let's see if
Okay.
we can catch this launch.
Okay. All right.
All right. You guys ready?
Are we ready?
Unmute so we can speak to you.
Hey.
What school
Yeah.
is this?
Bronx International.
Bronx
on,
International.
Bronx.
Hey, come on.
Are you gonna launch?
Are you gonna launch?
Yeah, now. No, now.
Yeah. Let's- Okay. Yeah. Launch. Are we launching? Nice. Great designs. Excellent. All right. I'm trying to get it together. I see. That's good. I see the rocket. Anyone want to talk about the rocket? Anybody want to talk about the rocket? Come on.
Somebody come on up and chat with us about your rocket, about your design.
Yeah. We need some conversation, right, Monica? Oh man, they're just letting them go. They just.
All right.
I see two more schools with their hands up. Let's
All
see.
right.
Let's
see. Let's see if this one's ready.
would
Northeast
be
High School, you
great.
ready? Oh, they look ready.
okay.
Go ahead, guys.
There we go.
Oh,
Excellent.
yes.
Great. Okay, that's excellent.
Successful launch.
Now,
It worked. It worked.
if we could get a conversation
Can
about
somebody come to the camera and talk to us about the design that worked?
anyone.
Wait, you were muted.
Can somebody come to the camera and talk to us?
It's a SpaceX rocket. It landed right back where we launched it.
Nice. That's right. What was the most challenging part of you creating this rocket? Talk to us about some challenges. Anyone? Oh, she's going across the room. Maybe we're gonna get some conversation. Maybe Monica. Maybe we're gonna
Maybe.
hear
No, I
about
think
the
we're going
engineering
back to
design
our,
process. Maybe
Mhm.
she's showing another launch. I'm not sure. Okay. All right. Okay.
Mr. Red, when you have your hand up, you ready to chat with us?
Yeah, I think we're ready. We had 3 successful get to the ceiling and only one of them had all the paper clips. So we're gonna try one here for you.
Great.
Here we go.
Don't you?
And it's a lot of pressure. Once the camera comes on, it's tough. Oh, it's the camera, Monica. Someone put the camera on. Man.
Let me try.
No, great job.
All right, East Harlem says they're ready to chat with us. So
Great
I'm gonna
job.
give East Harlem a chance to talk with us.
Okay.
All right, East Harlem, you ready?
Yes, we are. Hold on. Please come in. Israel, come on.
Okay.
Israel. Sorry, he's coming. Give him a minute.
Oh man, the camera.
Israel?
Don't be camera shy.
Oh, either.
We're friends. We're all friends here. We're all friends. Nope.
Okay, so we had like good five good successes, and it's
Nice.
because we took the balloon like this, and then we tied tape to the straw, and then we attached it to the string, and every time it would launch up.
Excellent. What was the toughest part of making the rocket? What was really hard about it?
The toughest part was having the right material.
That's good. And what are your plans after high school? You seem like you're on point. What are you thinking of doing after high school?
I want to go into the STEM field. I'm just not sure. Yeah.
That's all good. Excellent. Great job. Thank you.
Thank you. Academy of Mount St. Ursula says they're ready. Are you guys ready, Academy of Mount St. Ursula?
All right.
Unmute Academy of Mount St. Ursula.
Hi, so
Camera over there.
my balloon or my group's balloon, it's not, it's two of the long blue balloons and then on
So
the top.
face you. If you put it right there, it's gonna face this.
Okay, got it.
So we tied it with the fish line at the top, so it kind of can guide up. And then
Nice.
I left this here on the bottom on the floor. And then can you help me move the camera so I can show the ceiling?
Yeah, excellent.
Can you hold it?
That's a high ceiling. Wow.
So wait, show up. Okay. I hope it works.
Oh, no.
It's
The
one
launch-
of those days. It's one of those days.
Oh, I'm so
Oh.
sorry. We missed the launch from Academy of Mount St. Ursula. They were so ready to go.
Okay.
All
I
right.
think maybe we have a couple
So
more.
we're in touch with
Maybe a couple.
All right. I think, let's see. Monsignor Farrell, you have your hand up. Are you ready for us, gentlemen? Yes? Let's spotlight them. All right, gentlemen. Looks like they got some launches ready. Can you unmute and chat with us?
Are you ready? We're ready to go?
I'm gonna try two.
All right.
I think they're
Double
gonna
launch.
have like a
Yeah.
Oh.
nice. Excellent.
And the other
Oh,
one. Two.
Oh, very nice. Great. That's great. Excellent. That first rocket came back down to the same spot. That is really nice.
oh, Milton, I don't know if you see in chat. We have a video.
Oh
From-
man, that's a nice video.
That is a good video. Thank you, Monsignor Farrell. All right. Who else is ready for a launch? I see a lot of hands up.
I hope
Okay,
you gotta
this
be
classroom
ready
here.
for real. Tell them, Monica, they need to be
I know. This
actually
classroom
ready.
was waving their hands. Are you ready
We're
now,
ready,
Bronx
we're ready.
International? All
Okay.
right.
Yes. Can you
Look
see
at
it?
this.
Okay,
Now
that's
you
it.
can see it.
Grab a launch pad. Okay, three.
What? Countdown.
All right, that's right. It's all right. Real time troubleshooting.
They sealed.
No, it's all good. Great
O-ring
job.
problem.
Great try. Great try.
Oh.
I had really high hopes.
Did
on
you see that? That was a failure. Launch failure.
No, it was, you all tried. It's
You
good.
know.
It's great. Great try.
The balloon's actually sealed at the bottom, so they wouldn't open up.
Oh, man.
Yeah. All right.
No worries,
try.
AMSU. Send us the video.
Yes.
We'll highlight you on social media or something. We'll do it. Betsy said a sticky valve. That's
valve.
right. Like we have like dual fault tolerant valve systems.
All right. I
Right.
see I see this classroom. They're ready now. I'm gonna give them one chance. Let's go. They're waving. You guys ready? Can you unmute and chat with us? Oh, they're getting right into launch mode.
Okay. All right.
All right.
Take it.
Let's see.
They have a lot of excitement. I love
They
the energy.
do.
Look at the energy. Jude's crew is ready.
Oh,
Man. No, it's all good.
sorry.
we're not. This is one of those days, man. You know, it's one of those days for sure.
Okay, this crew is ready. All right. Bronx International, I'm spotlighting you. This is another group from Bronx International. Jude Lure's group. Oh, look at this. Look at this one.
Oh man, that's
Let's see.
serious. All right. They have it wrapped really tight as well, man. I wonder, maybe adding some extra pressure to get the air out of the rockets a little faster. Let's see. I'm gonna cross my fingers this time, Monica.
Let's, oh,
Nice.
yes.
Excellent. Great job.
Yes.
Bronx BXHS.
Yes, Bronx
Very
International
nice.
High School. Do you guys want to unmute and chat with us? That was a successful launch live.
We'd love to hear about
Great
it.
job.
Yeah, we love to talk to you.
Do you want to talk to us? No,
I
nobody's
think
going to
somebody's
unmute.
coming over. They're coming over to unmute. Nope.
No,
They're not. They're
no.
not.
All right, I think.
Yeah, outstanding job. Excellent.
All right, well, you want to try one more group before we go to the next part of the day, Milton?
Yeah.
One
If
last
there's-
one.
If a group feels like they're ready to go and talk, love
Yeah, they
that.
have to chat with us.
Even
Oh.
more important than it working is
I
us
see
chatting with you.
this classroom has their hand, they're standing up on the chairs with their hand waving. Let's see what's going on.
All right,
There you are.
we ready to go?
Three, two, one.
Oh, nice.
Oh.
No, that was great. I've never seen a rocket like that. That was outstanding.
Does somebody want to come and talk to us about that design?
What up? Can we show off
Oh.
ours?
I-
We got one successful launch.
I'm trying,
Okay.
who's
Oh, that's
speaking? I
good.
can't see who it is.
Emma Messer from the Hermitage ACE Center.
All right, I'm spotlighting you, Emma. Oh. Emma, where are you?
Oh my God.
All right.
Oh.
Okay.
There we go.
All right.
I
Trying to
think
get
that-
it
I think they're still
angled.
they're setting it up, I believe.
Oh,
Maybe they have to blow it up as well.
I would
All
just
right.
wait till we're ready again.
oh,
Never mind, they already launched.
Okay. Well,
we keep
East
missing
Harlem-
them.
East Harlem wants to do it one more time. That'll be
All
our
right.
last one, and then we'll
East
tag
Harlem
in.
one more time. I'm coming to you, East Harlem. Let's see.
Okay,
All right.
East Harlem representing New York. Let's do it.
Oh,
Excellent. Oh,
yes,
that's the way to end on a really high ceiling.
yes.
Excellent. Anyone from East Harlem want to talk to us? Can we get? Oh, someone spoke to us from East Harlem. That's right.
Yes.
We got someone. Okay, great.
All right, Milton.
All right.
Think,
I guess we are
There's-
ready to transition
yes,
to our final session.
to our
Man.
final time of the day where we're going to have Milton and Betsy. Your teachers were so kind to send us some of your questions. So they're going to go over some of your questions. And I can't wait to see what some of the answers are because I was intrigued by your questions. So,
Yeah, also, Monica, we have a spot in here where you can jump in and ask us some questions. So we're excited about that.
all right. Oh, I see there's a new Slido in the chat. Betsy just posted.
Excellent, excellent. So we're starting off first with some trivia. Space trivia, jump on in. We want you all to jump on in the Slido. We have some great questions for you. You got the outstanding Betsy, who knows so much about human space flight, and myself, who wanted to be an astronaut and never was chosen. So I know a lot about humanless space flight. I'll just say that. Betsy, you there?
Yeah, I am here. You guys, thanks so much for having us in your classroom today. It is super awesome to be here, and it is so cool to see all of your different designs. I love how unique they have been. So let's maybe jump into some NASA trivia. Hopefully you guys are getting into Slido here in just a second.
Yeah, we'll give you a minute. Excellent.
Here is our first one. On the left-hand side, you can see the QR code. If you have a device, you're welcome to go ahead and scan that and join us. If you don't have a device and you want to enter through your chat, that's fine too. Both work perfectly.
They work perfectly. There's that first question. First question. What is the most powerful rocket in the world? Who has it? Most powerful rocket in the world. What are we seeing in the chat? I'm trying to pull the chat back up. What are we seeing in the chat?
Chat's been kind of quiet, but you guys, this is so perfect because it goes right with what you guys just designed in your rockets. So I love this question.
Oh, we got Saturn V coming in pretty strong. SLS, excellent. SpaceX Starship Space Shuttle, that's great. Good. It's a nice battle here. Excellent. It's good. It's a tough question. It was tough for Betsy and I. Most data shows that it actually is the SLS. Saturn V was powerful. Maybe that SpaceX Starship one day is going to get it going, but you know, over 400,000 pounds of thrust for the SLS. All right, next question. Let's do another one.
Awesome. Here it comes. Ready? How big is the Milky Way?
Yeah, how big is the Milky Way? This is okay, 100,000 light years, 1,000, 10,000. 1,000, good man. They voted fast. You all are
Yeah.
too smart. You're right. It is 100,000 light years across, which means it would take 100,000 years traveling at the speed of light to go all the way across. And the Milky Way weighs so much that it would fit a 1.5 trillion suns in the Milky Way. That amount of weight, so it's huge. Excellent. All right, what's the next one, Betsy?
All right, our next one. Here we go. Who was the first American man in space? Who do you think? Oh, we got lots of Neil Armstrongs here weighing
Good
in.
old Neil. Good old Neil. Armstrong is coming in the chat as well.
I'm seeing some shepherds growing.
Excellent.
You guys are doing great. All right, so those of you that are thinking Neil Armstrong, you might be thinking of the first man on the moon. So I know we threw you off on this one, didn't we? So keeping that in mind, what you're noticing is all of a sudden Shepard is increasing, and you are right. Alan Shepard was the first man from America in space. He launched in May 5th, 1961.
Mm,
Can you believe that? That sounds like so long ago to me.
I
Isn't that
know.
crazy? All right, so right along with that question, who is this man? And how does it relate to the question right before this one? Okay, we got some John Glenns. We've got some Yuri Gagarins. I'm loving it.
Oh yeah. Even a Charles
Dude.
Brown. Nice. Okay.
All right. Curious if you know how this question relates to the previous one. Feel free to type it in the chat. Doo-doo-doo-doo. All right. The majority is winning on this one. High five, you guys.
They're crushing it.
Yes, they are crushing it. It's so cool. So this is Yuri Gagarin, and he was the first man in space. Again, the one we had before was the first American. You guys, guess what? He launched from the Soviet Union, and they launched in April 12th of 1961. So they beat us by a whole month almost, like 3 to 4 weeks. And that goes back to what Milton was telling you guys earlier about how it becomes very competitive in the space realm where you know, once Russia had launched a man, then it kind of upped our game to start launching humans, and then, you know, who could be to the moon first and that kind of stuff. So you can kind of see that there. All right, so let's move on to where. Yeah,
What's the next one?
here it comes.
Oh yeah. What metal is found in high concentrations in asteroids? One of the reasons we brought this up is because part of the future of space is asteroid retrieval missions, for sure. There's a lot of investment for a lot of different reasons as well. You know, there's the small chance, but there's the chance an asteroid could reach our planet and impact us. So there's different missions have investigated how to stop that from occurring, like DART. So, all right, man, you all are they're extremely smart. You're right. 50% iridium is correct. It is $2,550 per troy ounce. It's a very, very dense metal. And you'll see a lot of contracting companies, private companies investing in asteroids. They want to get that good material and use it for something. Okay. Next question. Great job.
Incredible. That was incredible, Milton. I can't even fathom that kind of money.
Yeah.
Right?
Unbelievable.
All right. So
Oh, I
our
love
next
this.
question. hmm Who is this person? Like, who was our first American woman in space? And what's the name? Okay, good. Look at you all. So, some of you are thinking Peggy Whitson, some of you are thinking Sally Ride.
Someone in the chat said Krista. Okay, all
It's
right. We're
awesome.
getting some engagement.
Yeah, all of these are some famous women that have flown. You are so right on all of these. The first one though that actually launched from America is Sally Ride. You can see here, Peggy Whitson was our first ISS commander that was a woman. And you can see down here, Krista McCullough, you're probably thinking about when Challenger occurred. She was one of the teachers that was selected. And you guys, I was in the 5th grade when Challenger exploded. And I remember watching this and, it was a huge tragedy for our nation. But I remember watching it and thinking, these people died for something bigger than themselves. And I absolutely want to be a part of it.
Yeah.
And I want to bring our country forward. And, from then on, I had my heart set on working in the space industry, whether that meant, working as an engineer or working as some other capacity. So I just wanted to point out that is our Sally Ride up there. And here is our next one. You may be seeing a pattern. Who do you think this is?
And they typed in fast. Right? It could be in
I
fast.
know, right? They are still on it today. All right, so lots of you are saying talent Valentina Tereshkova, and you are right. You guys, this is incredible. So Sally Ride from America launched in 1983, but guess what? The Soviet Union launched a woman 20 years before us, back in 1963. Is that not incredible? So cool. All right, here comes our next one. Are you ready?
Oh yeah. What is the most distant object explored in capital? Explored by NASA up close. We have Pluto. We have Venus. Ultima Thule. All right, the sun. Up close. Up close. Excellent. This is one of our biggest challenges is how do we get our satellites, our spacecraft further and further out. Pluto is coming in strong at 65%. That's good thinking. Pluto is very far from the sun. The answer is actually Ultima Thule. That was NASA's New Horizons mission near the Kuiper Belt that it traveled and actually took a photo of a couple asteroids that almost look like a snowman that are connected together. And Voyager 1 and Voyager 2 are the spacecraft that have absolutely gone the farthest, but from an inspection standpoint, it's Ultima Thule that was checked out. So that's great. All right. Good engagement. Next question.
So incredible. All right, going back to some of the first, here are some first American astronauts to launch on a commercial vehicle on SpaceX's Dragon. Oh my goodness, you guys are doing great. Look at all those answers. Oh, let's try it first. Pulling back. Oh, look at
It's a
you.
sharp group. It's a sharp
I know. They could be teaching this one, don't you think, Milton?
Yeah.
You guys
I
are
wish I
rocking
would have
it,
asked tougher questions now. Man, they're sharp.
right? So out of like 50 answers are already logged in. Look at you. You got it. It's Bob Behnken and Doug Hurley. And they launched on the SpaceX Dragon as the first crewed vehicle. And now you guys know that we are actually going on rotations with the SpaceX as well as the Boeing vehicles once Boeing gets its next crewed mission. You'll also remember that earlier in the day when you guys were in your breakout room, I sent you guys a link in the chat and we can replace it there again for you in just a little bit. Of the undocking and landing that just occurred. I believe it was Crew 5 that just undocked on Sunday night. So good times and exciting things.
Good times. Okay, I think we had a lot of questions today about exploring new life. Is life out there? How can we colonize? What do you think is most important? What are most important signs that we investigate if we want to determine if a planet could support life? I love that QHSLS said water. Water's coming in strong. Signs of atmosphere. That's strong. Light. That's strong. Yeah. Communication. What do you mean? Are we able to get a signal from some distant planet and maybe even interpret it, right? Methane, excellent. You all are killing it. Excellent. So, oxygen, carbon dioxide, methane, all those things are very important that give an indication of atmosphere. Atmosphere can give an indication that can support life. Light is important as well. There are certain wavelengths of light that we will detect with planets that give us information about their atmosphere and that they could support. Water's huge, very huge when we know how important water is to us in our world, and methane. So there was no wrong answers here. Every answer is correct. Great. And I think we have one more, right? Last one. We received some questions about space travel. We received questions about cars that fly, cars that go into space. So hey, what's the fastest object ever built? What do you think? Fastest object? Some hypersonic planes. We're hearing a lot about hypersonic planes right now. Nice. Rocket, yeah, satellites. We even got someone even voted just for the Tesla, said, hey, forget it. On the ground. On the ground. Excellent. Good. Yeah. You all are close. You're close. It actually turns out that it's a satellite. It's a satellite. The solar Parker probe that actually was, travel and run right into the sun, reached a speed at 244,000 miles per hour. Fastest vehicle ever built by humankind. So you're right, it's a satellite. Excellent. Okay. Thank you all. This was good. We got a couple more trivia questions for you. This is going to be tough. I'm going to ask you some questions as we begin to introduce ourselves and give you a little bit about our background and stories. Is it Milton or is it Betsy? Which one is it? Is it Milton or is it Betsy? Okay. Milton or Betsy, you guess.
Oh, I love it.
Yeah. Both is coming in strong. They think really highly of you there, Betsy.
Yeah, and you. It's so
I don't
good.
know.
Look at that. All
Yeah,
right. So
244,000 miles an hour is crazy. QH SLS. It's unbelievable.
it
Okay.
is. Oh, guess what? It was me. So I had the wonderful opportunity to take astronomy when I was in high school, but you guys, it kicked my butt. I'm not gonna lie. I was taking physics the same time that I was taking astronomy. And some of the equations that are involved about, how two objects have gravitational force between them and trying to calculate them. So it was a really tough course, but I was so thankful that we had a teacher there who was willing to invest the time and actually created the course kind of on his own. And I was so blessed with that. Speaking of those kinds of questions about high school, you guys had all asked some questions to us about, what classes and experiences are most important for students that are interested in aerospace or aeronautical engineering. And also, is physics highly recommended and that kind of thing. So Milton, do you have any ideas that you wanted to share on this as well?
Yeah, for classes and experience that are most important. One, I just think physics is a great class. It's like a great foundation for everything you're going to do. I really struggled with physics in high school, but as I started to apply it a little more, that was great. From an experience standpoint, we'll talk about this later. What helped me with physics is just engineering. Actually, experiencing engineering, maybe in a club, maybe on an internship. Those are great options. So next question I'll ask you, Betsy, is taking a physics class highly recommended for students interested in space exploration?
So I would say yes, definitely. If you have the opportunity to take it in high school, I would certainly take it. Even if you don't take an AP course, or even if you do take an AP course, when you get to college, and if you have to take it again in college, it's actually wonderful. I found myself taking calculus in high school, but then also taking it again in college, and just having that foundation and coming into college knowing some of it, so it wasn't so overwhelming, I found very helpful. And then just in general, as an aerospace engineer, having to understand, how things rotate, how things move, how we can calculate the forces behind things is all part of physics. And I would highly recommend any kind of physics or math courses that you can get yourself into. I love nowadays, you can have the internet at your fingertips, and it is incredible. So if you have a question about like a class when you're in college or even in high school, you can go and look up things. For me, I remember struggling. One of my worst courses ever was electrical engineering. And I remember having to drive home, and I won't tell you where because it's one of our questions, I think. I remember having to drive home every weekend to get tutored. Nowadays, you guys don't have to do that. Tutoring is at your fingertips. Anywhere you live, you can connect with someone online that can help you.
Excellent. I'll ask you another one, Betsy. Did you participate in a robotics club or team in high school?
Great question. So my high school was really small. In fact, I think we had about 88 or 90 graduating people in my class. We did not have a robotics team or any kind of club like that, but we did have Science Olympiad. And I was a part of that. And I really enjoyed that because it gave me a chance to see some of those hands-on learning experiences. And for me personally, I learn better when I have to do something versus just listening to someone talk about it. I don't know about you. What do you think, Milton?
Yeah, I think it's, even though I didn't have the opportunity, I love working with my hands. I mean, I learn much more through being active and solving problems than looking at equations. So for sure, and then it made me appreciate those equations and things even better. So I agree. But if you can get involved with robotics, Vex Robotics is outstanding. That's a great challenge for you to take on. Okay, what's our next one? Ooh, yeah, who worked with NASA as a co-op while in college? While in college.
Oh, I like it, Milton.
Yeah,
They were listening earlier. I love it.
yeah, I think they're paying attention. It definitely was a game changer for me as well. But Betsy was a co-op as well. You want to speak about your co-op experience?
Yeah, you guys, I co-opted at NASA Langley Research Center, which I was doing mostly aircraft at the time. I was probably a sophomore, and I remember sitting in classes, and I don't know about you guys, but raise your hand. Have you ever felt like you were in a class and were like, why is my teacher telling me this? Like, why do I need to know this? Don't computers do this? Well, I remember thinking that as they were explaining all the different equations about how airflow goes over the sides of the wings. And when I went to my co-op, we were placing sensors on the F-18 models and then sticking them in the wind tunnels. And all of that, like the theory came rushing back to me, those questions about why am I learning this? I could see why I needed to know where, airflow differed and how it all kind of fit together. So yeah, I enjoyed working as a NASA co-op. There were some co-ops that were easier than others. And I think every different job and experience you get a little more information about what you want to do in your final career. So I think that kind of helps.
Yeah. Another nice thing about the co-op is it's not just an internship for us. When we were in college, they hired us as a NASA civil servant. So I had access to benefits to help me pay for school. And obviously just, I was paid on that opportunity. So it was a great experience.
Yeah, for sure. And not only getting paid, but you get your time off just like normal engineers, and you get, you just get the experiences and contacts as well, which I totally love. Speaking about working, who do you think worked multiple jobs while co-oping at NASA?
Yeah, thank you so much, Dr. Anthony, for participating.
Yeah. So I'm getting some Bolts, some Miltons, some Betsy's. I love it. And some neithers. All right. The majority is taking it. You are right. So yes, we both worked multiple jobs. So it wasn't typical, at least it wasn't where I was co-oping at Langley. Most co-ops did not work multiple jobs. They just worked their NASA job in the day and then they relaxed at night. I chose, because I knew I had the time, I chose to work a second job while I was co-oping because I knew when I was at Purdue, I wanted to focus my efforts on studying. So I worked at NASA during the day, and then at night, I worked at a restaurant where I was a hostess. And I also took classes at night. So I did all three of those things while I was on co-oping, and I loved it doing that. Taking things like thermodynamics while I was on co-op freed up some time and space in my schedule so that I could take other classes while I was at Purdue too. Milton, do you want to explain your experiences of working multiple jobs while you co-opt as well?
Same here, just in college, college is not cheap. So hope you all are applying for scholarships. But in addition, you can work. I work in an undergraduate house. I worked in a lot of kitchens. I worked at a old country buffet, and I ate a lot of food there. And then I was a tutor, right? Sometimes you can use your STEM skills to help other people and be compensated. Okay, what's our next question, Betsy?
Our next question, who struggled on their internship?
Someone said both. Excellent.
Yeah,
Yeah.
you guys are seeing our similarities.
Yeah.
All right, very good. Majority is saying both. I think in a sense, both of us struggled because there were some coding things that really were difficult for me. But this one, Milton, do you want to explain what you found out?
Yeah, for sure. I mean, so I came from a high school that was, we just didn't have a lot of technology. When we switch back over to the other presentation, I'll have some slides that kind of highlight this. Didn't have access to a computer, and we only had like a half a semester of physics. It was a tough year, and a half a semester of calculus. So when I went to Purdue, it was really challenging to not just on the internship, but just traveling to Purdue and learning and trying to acclimate to that. But one nice thing is when you have an internship at NASA, they'll try to give you some real work and you have some great mentors. Unfortunately, because I didn't have any software skills at all, it was a pretty big challenge to work on a project where I had to actually code. Yeah, this is me. That's my high school, Westside High School. No software experience. Click that button there, Betsy. You'll see I throw them a big X on it. Then on the next slide, if you go there, definitely Purdue was great. Had to catch up on physics and calculus. Those are great classes. Catch up on programming. And then that next slide, Betsy, this is where I'm highlighting, man, that first internship was excellent. A lot of good hands-on experience. But then the second one, it was rough. I had no coding experience, and this high school student I was working with, he took Python as a junior. Like, who does that? They're like, every student here is like, oh, I do that. So he kicked my butt at NASA every day. But when I went back to Purdue, I really appreciated learning how to code. And I came back on my third internship and I used coding. Click one more time, Betsy. Use a program called MATLAB to really help me develop this nice design for demise program. And that kind of set my career. Great. Yeah. So, hey, you can turn these problems that you're having on internships and challenges into successes if you persevere. Keep persevering. What's our next question, Betsy?
Yeah, sure. So our next question is, who has over 20 engineers in their family?
Wow. 20 engineers. Nice.
Getting lots of neithers.
Smart class here.
Mm-hmm.
Intelligent class.
Yeah, for sure. All right, so you guys, most of you are guessing me, and you are right. So that is true. And this is just my blood relatives. So my aunts, uncles, my grandfather, my father, myself, and some first cousins. And we have 20 engineers, actually more than, I think 21. The majority are civil engineers. You can see up here, and the 14 are civil, aero, double E, so electrical, in case I'm throwing out some engineering lingo, sorry about that. Computer and electrical combined. At the time it was called that. Engineering management, and then we also have 3 mechanicals. Of all of these 21 engineers, 2 have gone on to become patent lawyers. which is a really cool career path that you don't often hear about, where you take your engineering skills and your background and you analyze new designs that are out there and you figure out, is this truly like a new design? Does it fit and meet what patents are and things like that? So we're going to talk a little bit more about patents in just a couple of slides as well.
Excellent, excellent, nice.
All right, who do you guys think struggled to read in elementary school?
This is a great question too, because I think a lot of people assume that you had to be the smartest person in high school or elementary in order to become an engineer or a scientist. And that's not the case. That is not the case. Oh man, I love this. QHSLS says Milton as well. That's good.
Yeah,
Jillian
says
neither.
neither. All right, should we let him know?
Yeah.
Okay, so it was me. I actually struggled reading. I remember third grade was awful. I mean, awful for me. I remember my mom working with me through the summer. I used to have to read my books, especially my science books. I would take them into my closet and I would shut the door and I took a tape recorder in. That's how long ago it was. And I would read my chapters into the tape recorder and then I would play it back to listen to like what I read because I couldn't understand what I was reading at the time. Now I know that like it's probably pretty similar to what dyslexics are going through. I never was officially diagnosed, but there are several people in my family that have since been diagnosed. Remember those engineers that we just saw on the previous slide? It's that family that we have multiple dyslexics as well. So, if you are finding yourself, having difficulties through school, you can absolutely become and do wonderful things. Don't let it stop you in any way. Just be ready to like put in the effort and the work and it's there for you. All right, here's our next question.
That's the next question. Who has a patent?
Remember when we were talking about patent lawyers?
Who has a patent? Both, excellent. That's nice. We got some both, some Miltons, some Betsy's, excellent. That's good.
Yeah, it is.
Great. Yeah, I think I told you all about how I struggled with computer software as an intern. Hey, Bronx International. And it was really nice about struggling that internship. I came back and with some coding experience, I obtained my first patent. First patent was for designing a system that can ablate or demise upon re-entry. And that was in college. So that really inspired me. After that internship where I didn't do so hot, I really thought, man, I don't know about this engineering stuff, but thank God I came back strong. And then I got a couple patents for other systems, like the processing system inside of LiDAR, which is great. Hey, Bronx. And helping to develop this GPS receiver. And the nice thing about patents is, they're cool inventions. It's nice to have an invention, but every time somebody buys that invention, you get paid as well. So it's really cool to work on a team that makes something that no one has ever created before. Okay, what is our next question?
Our next question is a quick question about how many people do you think are on the space station right now?
How many? Your engagement has been outstanding today.
Yes, it has. It's incredible.
We're getting 11 out of people.
Oh, yeah.
is
All right.
7.
Very good. And I'm just jumping ahead to where that is. Okay, so when we talk about how many people are on the space station, we have to look at how many people are on each vehicle to get them home. Because when you can get up there, but just to leave people on the space station without a way home can be a problem. So right now, we have SpaceX vehicles that can hold 4 people, and we have the Soyuz people or space vehicles that can hold 3 people. Currently on board, we have 7 individuals on orbit, and that's due to having their rides home, right? So those vehicles just couple days ago, though, I mentioned that we had a crew undocking. And so that was a SpaceX vehicle as well. So if you answered 11, you were only 2 days off in the fact that we did have an extra 4 on board at that point and until we did the undocking. So great job. All right, Milton, I apologize. I kind of sped through some of our slides here. So I'm going to take a step back and just explain like kind of who we are a little bit more now that we've gone through some of our questions.
Excellent.
As you heard, Milton went to Purdue and so did I. I really chose Purdue because it was strong in engineering. It had lots of engineering aspects to it. And then I also looked at Purdue because I knew that it had a lot of astronauts that had come from there. And I knew I wanted to get to the space program. And that was my ultimate goal. So that's why I chose Purdue. You can see NASA Langley Research Center is where I went and did my co-oping. Again, I was a sophomore in college, so I wasn't that much older than you when I started my engineering job as a civil servant. From there, I graduated and went down to NASA Johnson Space Center, where I began training the astronauts with a team of astronaut instructors. It wasn't just me, but my job was to teach the guidance, navigation, and control systems. So like how we orient the space station with respect to the stars, how we perform reboosts and do those kinds of things. And then when I was doing that, I had to work with the Russian computers quite a bit to get them to talk to our computers in the simulator so that we could make sure we weren't force fighting and having those kinds of problems. And so after that, I went and became what we call a Russian training integration instructor, where I got to teach the astronauts all the different Russian segment systems. So I traveled with them to Star City, Russia. They're a lot like you guys in the fact that they sit in classes, like theory classes during the day. So instead of going to like algebra and history class, they're going to the EPS or the electrical power system and the guidance system. And so those are their classes. And then when they take their exams, they have to do some theory exams. So explaining how systems work. And then they go and do the actual physical simulations as exams as well. And so those are just some of my experiences there. When I came back to the States about 6 years later, I joined the astronaut office as their chief engineer for exploration, where I was working on what we used to call Constellation, which is what I'm wearing today, this shirt. We now call Artemis in the Orion program. And then on the right, you can see the Boeing and SpaceX vehicles. We were laying the groundwork for what we now know as commercial crew. So that's kind of my background in a quick nutshell. Milton, did I skip past yours? Do I need to go back?
No, keep going. This is just showing the patent slide. And in the chat, there's a question about did we both go to Purdue? Did we overlap? I don't think we overlap, but I think it would have been pretty cool if we could have overlapped. We could have been study partners. Maybe taking those orbital mechanics classes would have been a little easier if we could have doubled up, right?
Dude, those orbital mechanics classes, I don't know, you guys. When your mentors were talking to you back in the Q&A and they were talking about how long the homeworks could be, those orbital mechanics ones would take me an entire engineering pad paper for one homework assignment. Like it was insane. I don't think we overlapped. I graduated in 98. So I think I'm a little older than Milton.
Oh, just slightly. I graduated in 2004. So we're not too far off.
Gotcha. And did I have to learn Russian? Yes. If the astronauts were in classes and did not need an interpreter, then I could not have an interpreter either. So it was a little bit of trial by fire those first few years where, I didn't necessarily know the language right away. I had taken some classes, but what I found was I would go to classes with the astronauts all day for 8 hours. And then after that, I would go and have my own separate Russian classes for another hour, hour and a half. Every day, including Saturdays. And, over time, when you're hearing words like depressurization in Russian, you hear it enough times that you know what it is. And so it eventually got easier. For sure, the second and third and fourth years were easier than the first.
Excellent. There's another question in the chat. And while you go to the next slide, I'll just answer it. What makes university engineering programs better than others? I think, a lot of the engineering programs are great. Let me say that. No shade. I know we're definitely not going to diss any programs. Part of it is they may focus in on a specific niche area that you're interested in. Some of them are really good with aerospace. Some are good with electrical. Some are good with computer science, like full stack development. It really depends on what you want. But I really like the type of schools, you all are very welcome. I really like the type of schools that do really well with involving students, like good lab work, good experiences, good hands-on work, good internships, all that great jazz is outstanding. So we're getting a lot of thank you all, thank yous in the chat.
I
Those
know.
who can stick
incredible.
around.
Sorry, they're thanking you because we need to go and they didn't want to interrupt. We have a
Oh,
closed
we
page,
appreciate
so.
that. Thank you so much, Christy McKenzie. You know what I would like to do, because we are getting a few teams that are moving forward. We have a question from the audience about a day-to-day life. I want to move forward to that on slide 34. East Harlem, how you doing? Great to
Okay,
see
we'll
you.
jump to slide 34. Yeah, good questions.
So we got this question about what the day-to-day life is for both of us. We'll both talk about it and what part of your job is your favorite. There is something I want to highlight though, if you go to the next slide. I mean, a lot of students have been asking me, all right, okay. A lot of students, oh, thank you so much. You're very welcome. A lot of students have been asking me about different, like what is the path to actually developing a spacecraft? And you know what, Betsy, I don't see it on this slide here. Maybe let me do this. Let me pull up my screen. I think I'm looking on slide 34 if you're on there, but I can pull up my screen as well.
Yeah, if you want me to stop sharing and you
Or
share.
35 maybe it's 35. Okay, yeah, I'll share, no worries, cool. So
Yeah.
this is kind of the day-to-day life, like how do you develop a mission? So what goes on when you're developing these missions is they do something called a decadal study, where a bunch of really smart people from across the world, they're going to try to determine like what is that next game-changing mission that we have to decide on for the next 10 years. What do we need to explore? And before I was at NASA, someone thought, hey, there's some interaction happening between our sun and the earth at the magnetosphere, the part of the sphere that protects our earth from solar radiation. It actually is the reason why we have life on Earth and Mars doesn't, because that solar radiation can really deplete all life. So then, some scientist comes in and he says, hey, I want to discuss, I have an idea. And he said, hey, there's something going on up there called magnetic reconnection. Crazy term, right? There's all this energy that's being collected. I want to investigate that. And he thought in order to investigate it, I need 4 satellites. That's kind of his idea. And they need to operate in a tetrahedron and stay tight to get a 3D kind of concept so then they came up with this mission called MMS, which I love, the magnetospheric multi-scale mission. And then as part of the engineering design process, you come up with a mission design, but you come up with a design. And he's like, well, how am I going to get all these satellites to fit in the rocket? Where we're going to stack them up? What are all the different components that we need? I actually got a chance to work on the GPS receiver to help design that, which is critical to those satellites staying in this tight knit, okay? And then you get a chance to work on other enabling technologies. That GPS receiver, it ended up getting the Guinness World Record for the fastest orbiting and highest orbiting satellite in the, GPS receiver in the world. Still holds that record, which is cool. And then, we didn't develop the Star Trek at NASA. Some folks from Denmark developed it, and they had me go out there and kind of research with them, help them develop their Star Tracker. So you get a chance to meet people from across the world and some really critical enabling technologies. And then after you have your design, it's time to build. You start building the smaller things first. This is me building the GPS receiver. It's crazy, right? And then you want to install it. Then you install it on the spacecraft. And then after you have it built, you start integrating the spacecraft. And then we started stacking all the spacecraft together till we got them in 2 stacks. This is all that engineering design process stuff. Then, just because you built it and designed it doesn't mean it's going to work. Some of you all experienced this today with your rocket, where you put it on the launch stand and it didn't work. Well, one thing we do at NASA is we test as we fly, right? We test as we fly. So before we launch it, we try to test it through all those crazy environments, like vibration, like the fact that the satellite is going to orbit around the Earth and the moon is going to get hot and cold, or like radiation, right? Which can zap the electronics. So this is MMS on a vibration table. We vibrate it to survive that launch. And then we bake it, we shake it, we bake it, right? In a thermal vacuum oven, we radiate it so we don't get that crazy, communication and interference. And then we do some radiation testing as well to make sure parts survive. Then after that's done, you know, we bring in all the parts. You know, it's not just NASA. JAXA helped us with the mission. Denmark, we talked about that. Some folks in Austria helped out with an instrument. We bring them all together. And then it's like time to ship it. We ship it to Florida and even the Texas places that Betsy has been often. Install that thing inside the rocket. This is inside of the fairing, and then we launch it. And the biggest part now after that is just like you all, when we put the camera on you and you're hoping and praying that the rocket launch, we're hoping. Like some of us are praying, some of us are crossing our fingers, just hoping this thing works. This is me in the control station, just nervous. Then at some point, you know, it actually, you know, releases, and it successfully releases. This is it releasing from the rocket. One of the all 4 satellites releasing from the rocket, which was crazy. That part worked. And so you deploy it out there, and then finally, you know, you get all these different
Each one gets
operating in space and working. And once they're deployed, there's a lot of different mechanisms that needs to deploy as well. So we're hoping that the mechanisms deploy effectively, and all of that stuff worked because we tested a lot. We test as you fly, so that worked out really, really well for us. And then there's the success, right? You know, it works and people are just so excited. But it's not just one person, there's a team. You know, you got your project manager, you got your scientist, you got your system engineer, and you got me all the way in the back. I grew up on this mission, so that was a long time ago, but you all the way in the back. And after that, you're thinking, man, that's great, but I want to pay it forward. And that's why we're doing this today with you all with Engineering Tomorrow. We want to pay it forward. You know, we want you all to also achieve the successes that we achieved. And hey, that's one thing I'm doing with Engineering Tomorrow is we get to reach you. Betsy and I get to reach students from across the country. And I have highlighted a couple, you know, teams I helped build and launch some rockets, and even some high school students who got a chance to build and develop a payload that launched on a suborbital rocket, which is crazy cool. So that is for all you all who are interested in the day in the life of an engineer. You heard a lot about that. Betsy, I know you want to jump in as well. What's the day in the life of an engineer? And I'll stop sharing.
Yeah. No, you did great. I think it totally depends on the project that you are on. So the day-to-days that I was working in Russia and training our astronauts, it was like going to school. Like I would be in classes and learning, and they were drawing, you know, pictures about descent and landing, and I was taking notes just like you guys. And then when it came time for the simulators, that was kind of the coolest part. You get to sit in the simulators. For me, I enjoyed working in the Soyuz simulator the most, because usually our astronauts would be flying what we call left seaters, and so they're kind of like second in command to the pilot. But then when they're doing their separate, you know, simulations without the full crew, then there would be, you know, other tasks that had to be fulfilled. And so I got to sit, you know, inside the simulator and throw the switches just like some of our astronauts did. So I really enjoyed that. I also spent a lot of time in the simulators over in the area for space station, where, you know, it basically looks like this big long tube where you're operating the different systems, like how to clean out carbon dioxide and all of those things as well. So that was kind of the operations and like training, which is very different than when I switched over to like the Orion program, where we were still kind of in that design process phase. And so it may be, you know, a little more meeting intensive, but you're actually talking about, you know, what is the requirement? What do we need it to do? And is that feasible for the human? And then we actually go and test it and see things out. And so, you know, it just depends on which aspect of the mission that you're working on, and you find what you love best. Like, you know, are you more the operational, like let's use the machine and be the person operating it, or do you want to be the person designing it? And, you know, what is your strength? And so I find that's true in any engineering field. You find what you love to do most. And if you are doing what you love most, you're going to be magnetic. People are going to want you a part of their team. They're going to want your involvement. Don't you think, Milton?
Oh yeah, for sure. I mean, if you're working in your passion, you're working in your strengths, they are going to, you know, love what you're doing for sure. And you're going to love what you're doing, and you're going to have the best impact. And I know we're a little lower on time. Are there any questions we want to hit from the chat as well? Any questions in the chat? Let's see what I see. Do I see any questions in chat? There was a question about the in 30 to 50 years, like what aspect of aerospace industry? Betsy, don't we have a question that talks about the future of space? Maybe we
We
can
sure
wrap
do.
up with that.
Yeah, we sure do. So jumping quickly to there, so you guys have hit on some of the aspects of, what are challenges to human space flight now, whether that's human or humanless. So our robotics missions, our satellites and all of that, having the power, being able to deal with low gravity, being able to propel ourselves and things like that, right, Milton?
That's
Um,
right.
And then moving forward, if you're looking for human space flight, there's a couple added things. Having
Excellent.
water, being able to manage waste, making sure that we don't have any problems with our, muscles and things like that. You can see on this slide here, without gravity, we have to be able to run on our treadmill. We have to be able to, tether ourselves down. The astronauts up here are all using like footholds underneath where they're kind of keeping themselves in place for that particular picture. If they're sleeping, they have to be attached to the side walls. So all of these things, they have an impact now, but they also have an impact in where we're heading in 30 to 50 years. How much water we have and food. If you guys took the lab, our water treatment lab, this is the water treatment area on space station. You can see some of the cylinders where it's, making sure that the contaminants are getting out, how we store the water, food that Milton already hit on earlier
Yeah,
in
oh,
the
yeah.
wrap up slides and things like that, and how we do hydroponics for, feeding, if we needed to be able to grow our own plants and things like that. Being able to use the restroom, and protecting ourselves from radiation. So a lot of times we don't think about that, but under Earth's atmosphere, we're kind of shielded from some of the radiation that's happening out in space. And so our astronauts wear these things called dosimeters, and you can see a picture of those here, where it's kind of monitoring how much radiation they're getting, both instantaneously and then like cumulatively over their flights. And then the toilet, obviously, if you're going to space, you're a human, you're not just doing the cool, fun astronaut things, but you're also your plumber and your electrician and all those other jobs that you got to do to like
So cool.
maintain it. You can kind of see here is one of the astronauts trying to fix the toilet in this particular aspect. And then jumping forward, the future of space flight. So going right along with that question you guys asked, Milton.
Oh, this is a great one too, because someone in the chat brought up just a quick question about what missions we're on as well. So this allows us to kind of elaborate on this as well. Da Vinci is the next mission that I'll be supporting. It's a mission that's going on right now where one of the futures is exploring even more distant planets. So we're sending a probe to Venus to investigate the origins of that planet. And it's literally going to be dropped into the atmosphere. And as it's dropping, it's collecting all this different scientific data about the atmosphere, about temperature, all this information. And then hopefully it gives us a better understanding of the origins of that planet as well. And I know we are about at 1:50 now. We want to, before we open it up for Q&A, I did want to say to you all, outstanding job today working on your labs. I wanted to highlight just briefly, if I could steal the screen from you, Betsy, just one of the videos that the students sent us that was just absolutely outstanding. Great job. They took this to another level. So
Let's go.
did you see that? A horizontal launch. It was beautiful.
Let's go.
Excellent.
So fast too. I love it.
Oh my God. Thank you all so much for this opportunity. We appreciate you all. Maybe Betsy, we could do a show that last slide for resources that talks about future steps before we wrap.
Yep. Let me go ahead.
Go ahead, Monica.
Oh, no, I don't know if you guys saw the last questions in chat, if you wanted to hit on those before you wrap
let's
up.
do it. Let's do it.
Sorry.
As you're pulling that up, there's a question about our ED work on projects right now. We hit that. If we find bacteria on Mars in the future, how do we know that it originated from Mars, but was not brought from, by space probes? That's a great question. I think when we travel to Mars with spacecraft, especially the rover, we do try to make sure they're extremely clean. But what you asked is it's a really good question. You know, anytime we travel, there is a potential for us to bring something foreign to the planet that we're actually traveling to. Excellent question. And I can see in the chat that we got a bunch of resources up as well. Betsy, do you want to talk about some of these resources that we're giving them?
Sure. So if you guys are interested in doing some kind of NASA internship, there is a link for you there. I believe NASA hires both high school and college students. So you don't have to wait till you're in college if you are interested in working with NASA. For sure. A lot of you guys had some really good questions about, you know, some of the tests that Orion is going through and some of our other programs. You're curious, NASA has such an amazing website out there. The NASA image and video library is, you know, you can go out there and look at all the pictures that are available. They will do a really nice job too of explaining what you're looking at. So if it's a static fire testing or something to that extent of some engines, you'll see the captions explain what they are. So check out that if you're curious about what tests have been going on and what's going on now. There is also a podcast. I love this one. Houston, we have a podcast. So if you want to hear, you know, the day in the life of a particular engineer, they've got those out there. They have information from the astronauts out there or a particular, you know, science experiment. So all different kinds of information out on that podcast if you want to go ahead and subscribe to that. Space Camp. Milton, did you ever go to Space Camp? I didn't.
Never went to Space Camp, but it is a really, really cool opportunity. I actually sent a team there for my nonprofit. A bunch of students went down there and they got a chance to live the life in the day of an astronaut, but they also got a chance to build some really cool projects. And one thing I learned, there's multiple space camps. I thought there was just Space Camp, but across our country, there's some other space camps that they're developing to give you all like a real experience with maybe even be an astronaut for a day, maybe experiencing underwater, how it feels to have less gravitation, how to develop instruments. We can pull even more resources together because these are really great, but there's some other space camps across the country that you should try out. You should try. In addition to space, they try them out.
Yeah, for sure. I didn't go either, so I was wondering. The next one is one of my very favorites, and it's an online planetarium. It's called Stellarium. I might be butchering that name, but stellarium-web.org. When you pull this up, you can see exactly what your night sky would look like as you are standing outside. There's a night mode, so it will switch to red light. When you pull it up as well, you can say, I want to find where International Space Station is, or I want to find the latest satellite Milton's working on. And you can type in the name and it will take you straight to see them. And you can watch it like traveling across the sky. It is so cool. I highly recommend checking out Stellarium if you are interested in astronomy or any of that kind of details. Again, we already saw in the intro, Milton did a fantastic job of showing you just the progression of how big our rockets have gotten over the years. This particular video shows it kind of like in that bird's eye view perspective, if you're interested, as well as some summaries about what Artemis and Orion are doing and how the Commercial Crew Program is also pulled into some of the Moon and Mars planning that's going on.
And then finally, some resources on, like you said, Artemis and Orion. As we wrap up here today, we want to say thank you all so much again. If there's any like final questions, we'll take them. But I do want to give Monica an opportunity to talk about what's next.
First thing is, I want to say thank you to Milton and Betsy for leading such a great end to our amazing space day. All of the students who participated were out of this world. Those rocket launches were amazing. Sorry, we couldn't get our timing down to get our cameras to you while you were launching. We tried our best. This was a phenomenal day. And if you guys can stop sharing, I just want to share my screen to let everybody know about our upcoming electric vehicle day. Please make sure that you sign up for our next day. Milton is going to be back presenting that day. So if you love Milton, you can come back and check him out for our EV day. And we are so excited that you guys had a great day today. Don't forget to complete your exit tickets, teachers and students. So we will share with that along with the recording. And again, thank you everybody. Phenomenal day and look forward to seeing you again for more engineering tomorrow.